Good day, good people. Welcome to JJ Tech Tutoring. Today I just want to teach you how to prove that sin x, the derivative of sin x, is actually equals to cos x, right? So this is a proof, or you can just use it as a question. They might ask you, find the f prime of sin x using the definition, right? Or they can tell you that prove that sin x is equals to cos x. So this is another way of proving it, right? You can use the first principle or the definition, right? Now, first thing first, we need to have f of x plus h is equals to sin x plus h, right? So that means this here, we put it here, and then this one already it's this, right? Now let us now go to substitute in a formula. Lim h approaches 0, f of x plus h is sin x plus h, right? Minus sin x divided by h, right? Now this is how it is. Then from there, we need to apply the compound angle identities with this one, So this one is equivalent to sin x plus h is equals to sin x cos h plus cos x sin h. This is the simplest one to memorize, right? We then need to say sin x cos h plus cos x sin h minus sin of x, right? So this is that identity, a compound identity, right? So this one is just the f of x as it was given, now divided by h. Lim h approaches 0, right? Now what we need to do now is to find the factor sin x. There is sin x here, so we can just say sin x cos h minus sin x, right? Plus cos x sin h, right? Now all divided by h. Lim, right? So here we can still break this or split the fractions, but before that we have to factor out sin x cos minus 1, then divided by h. We have split it, then plus cos x sin h divided by h. No one will say no. No one will say I don't understand here. So we have split it. You need to understand by force now, right? They have split it. We have split it there. Understand? Because firstly we factored out sin x, then cos x h minus 1. Then from there we splitted them. Now lim h approaches 0, right? So now we have a limit of a sum, right? We have the limit of a sum, right? So let us go with it. We have a limit of this sum and the limit of this sum. Now let us put this in a proper way. Lim h is to 0. We have sin x cos h minus 1 h plus, now here we have to close this one, and then we have a limit because it's a sum, cos x sin h divided by, remember when you were taught the limits, grade 12, we used to use x every time x approaches this. What is it gonna do, and all when we were factorizing and do all those things. Now here h approaches 0, not x approaches 0, right? So now we have to take this outside, and then then have our limits properly. We have to take this, which is having x outside, then we have our limit properly, right? So now sin x lim h approaches 0 cos h minus 1 divided by h. Sorry about that. Right, then lim h 0, right? Then we also have to factor or take out this cos x, because now we are dealing with the approaching of the h to 0. So we can take this here, right? Then we have sin h 0 divided by h, right? Then from there, we're still going to prove this in another video, right? That this part is equals to, this part is equals to 0. We will prove it. I'm going to prove it for you. And this part is equals to 1, right? But if you can't wait, because there are people who say, I can't wait to know. For now, you just have to know, because if you use your calculator, you are going to get 0 here. If you use your calculator, you're going to get 1. But then someone will say, I never get that. I get math error. Yes, I know. So you just have to put any number that is close to 0 here. You can say 0,00001 or 0,01 here, and then 0,01 here. You will get 0, 0,01, 0,01. You will get 1, right? Then from there, we're going to have sin x multiplied by 0 plus cos x multiplied by 1. Then the answer is cos x. Right. So don't forget to like, share, and subscribe, or like and subscribe, please. Thank you so much, and good luck on your exams.